So I've scheduled a meeting today for an hour, and I have probably more content than would be appropriate for an hour, but I want to fill as much background information as necessary to have a good discussion. And then I'm really looking forward to hearing from you all to see what you would like us to do for a BNF scenario for LASSO, because there's a lot of options we've been talking about over the last couple of years, and now it's time to really get down into details and get serious about LASSO developing this new scenario for this fiscal year. So I do want to call out, Scott is the co-PI with me on LASSO, so he's on the call. He'll be taking notes and managing the chat. So definitely, if you have questions, you can drop those into the chat. Occasionally, I'll stop for a couple minutes at a time through the slide deck to get just quick feedback if somebody has a question they want to do verbally. But some of those just intentionally to get through where we want to go today. I'm going to keep those interactive times short sometimes, and chat might be more appropriate for some questions. So you just keep that in mind. Let's see here. There we go. So basically, just a little bit of background on LASSO and BNF observatory that ARM's deploying right now. I sent out a link to everybody that registered for this meeting to fill out a survey to see what your interests are to help us kind of plan for this meeting and see where people are at. So I have a couple slides I wanted to talk about that. And then most of the time I'll focus on what are some scenario options on priorities and where you all think we should be going. So that's kind of where we plan to spend our time today. Those of you that attended the ENA workshop we had a couple weeks ago, this slide is basically out of that. If you're not familiar with LASSO, just very high level, we produce simulations for the ARM facility, typically on the kilometer to Large-Eddy Simulation grid spacings. And we do this in what we call scenarios. And the scenario is essentially a grouping of simulations targeting a specific location where ARM has deployed instrumentation. And we do that around specific weather regimes. So the next slide, I've got examples of what we've done so far. So I'll show that in a sec. Kind of our goal in this LASSO activity for ARM is to help by identifying useful cases that the community might be interested in using for their research. That helps focus activity around particular dates and types of processes. Once we've identified those case dates, we then traditionally been doing ensembles that look at model input data to help understand the variability of that around the different cases at the location where the scenario is focused. We also demonstrate different model configurations and essentially try and come up with kind of a foundational modeling that can be used by the different research groups and PIs and other scientists to then build up and do their research. So essentially, we're trying to help speed up research that's funded by DOE and other organizations to make it easier to work with ARM data and do modeling around the ARM sites. So with that, I mentioned we've got 3 scenarios in the bank right now, or on the library shelf. The first one we did was around shallow convection in Oklahoma. The second one was organized deep convection during the cacti field campaign in Argentina. That was a pretty fun one with a lot of big deep convection in the LAS. And we're now in the process of essentially almost complete rollout of the LASSO ENA scenario. We've got another bank of or batch of simulations that we've just completed. We'll be releasing those in the next month or 2. And we're getting pretty close to essentially being done with that. So now it's time to start focusing on BNF. If you missed it, a couple weeks ago, we had a release meeting where we talked about what's available for the ENA scenario now. And when you get this slide deck later, there's links for the recording of that and slides. And Scott is going to post in the chat those links as well. So if you're interested and you missed that virtual call-in meeting about a month ago, you can check those links out to get more information about ENA. So that's kind of my big roll-up of what is LASSO. And I've got one more slide here, and then I'll pause a little bit to see if there's any questions. This is my BNF in one slide kind of quick summary of what BNF is. I'm hoping many of you on the call are familiar with what observations are available at BNF and possibly even working with some of the data but I know some of you are not. So I wanted to have a little bit of information about what is BNF. So BNF stands for Bankhead National Forest. This is about 70 kilometers west of Huntsville and to another 70 kilometers or so to the south. You can see in the plot here, this M1 facility does my cursor show up in this mode, Scott? If I move the cursor around?
You can if you move it. Yeah, I can see it.
Okay. So where I'm kind of circling with the cursor here, this is site M1, which is the primary mobile facility location. At that spot, there's the full deployment of the Kaiser radar, the AOS for the aerosol measurements, different radiometers and LIDARs. And very nearby, about a kilometer away, there's something quite unique for ARM is this tall tower. It's about a 43-meter tall tower that's instrumented up the sides with anemometers and temperature measurements, things like that, which is quite a useful platform that's kind of unique within the ARM ecosystem, so to speak. So that's a great new opportunity we have. There's also measurements in the forest. For example, here at S14, it's pretty close to this tall tower. So we're getting flux measurements within the canopy. Another unique feature that's essentially bringing this mobile deployment closer to what we traditionally think of as the permanent sites is these supplemental sites that are outside of the main primary facility. So about 30 or so kilometers away, we have S20, 30, and 40. And these are additional sites where we have profiling measurements, radar wind profilers, different things like that, that are available to give more context around the main facility for variability and to develop forcing data sets for things like RNL and other products like that. We also have the ARM radars out there. So there's the scanning precipitation radar up here close to the lake up there. And then between that and the main facility near Melton, there's the scanning cloud radar. And then as we'll point out one of the later slides, there's also IOPs with guest instruments that are bringing additional radars that are available in the area, as well as the Weather Service traditional radar that's available in the region that kind of just supplements everything that ARM is doing already. So this deployment is planned for 5 years, so it's quite a long time. This will allow us possibly to do different scenario options for BNF. So one of the things I wanted to highlight today is we need to kind of get started this year. We'll be able to start prototyping simulations for a LASSO scenario, but we can also, over time, during the 5-year period transition, and probably do different kinds of scenario configurations as well. So don't feel like we're locked into one. I want to hear what the community needs and wants out of ARM for this, and we'll see where we go over time. The other thing I wanted to make sure I highlight here on the top of this slide, there's a BAM's early release description of the BNF site that is available now, and there's the DOI if you're interested in that. Scott, I didn't pull the link for that, but
it's already in the chat.
Okay, great. So you can click on that as well if you're interested to get a little more information on all the different instrumentation that's available. So with that, I wanted to just stop and have maybe 2 or 3 questions if there are any about BNF, and if people have questions about the overall LASSO concept or where we're going to go today as we dig into the details here. So now we're kind of getting into the kind of the new stuff. So I mentioned I sent around a survey about a week or so ago to everybody registered on this call, and we sent it around a little bit broader group as well. And we've gotten about, let's see, I think it was 26 responses as of yesterday afternoon. So I have a quick summary of what people are showing an interest in up to this point. So it's not a large sample, but it's definitely enough to kind of get a sense of getting started in that. If you haven't filled out the survey yet, here's the link to that, and the QR code goes to that link as well. Scott also put that in the chat. So one of the things that's really become clear, BNF, its science foci are broad. There's interest in terms of the overall campaign itself in aerosols, in clouds, aerosol cloud interactions, land atmosphere interactions, and the variability of land cover impact on clouds, as well as a contingent of folks that are interested in the forest ecosystem, boundary layer processes, both in and above the forest. So there's a lot that could be done with LASSO. So in the survey, I just kind of made a list of these different possibilities. I asked people if we did simulations for these different processes, which ones would you use? And this is what popped up kind of at the high level. Users could click on as many as they were interested in. So it's not one per person, so to speak. So they might be interested in multiples of these. And this is kind of where it shows. And a lot of the processes are around clouds. Kind of the bottom of the list here are mostly cloud related. Deeper clouds towards the bottom, shallow clouds in the middle, and then we get up into the land atmosphere interactions and boundary layer processes. And really what becomes clear is that pretty much all these processes are of interest to at least somebody, and potential for doing something around LASSO for the modeling aspects. We could dig a little deeper into this. And so what I've listed here is I also allowed people to rank up the different topics they're interested in. What are the most important to least important? So here I'm showing the numbers of respondents for the top 3 rankings, essentially. So the left column here is how often somebody ranked each topic as the most interesting to them. And interestingly, aerosols actually pops up to the top of that list. So that's something we wanted to talk a little bit about today. Now, this is a bit nuanced. So obviously I broke out into a lot more specific detail, the different types of clouds. So in total, maybe it's similar numbers of people interested in aerosols and deep convection. But in total, there's still a definite interest in the aerosols as well. When you start looking at the top 3 combined, boundary layer processes really pop out as something of interest. And that's kind of makes sense because those will impact the clouds and things like that. The forest ecosystem didn't pop up in the top 3. So the people that checked that had it as a lower priority overall. In the clouds, pretty much the isolated deep convection and the kind of synoptic organized convection also kind of start to pop out as higher numbers of interest when you start looking at the top 3 rankings. Interestingly, what did not pop out, I added a couple topics on the bottom of the list here at the last minute. These are based on discussions that we've been having in the ARM organization as a whole, and a workshop Jim held recently to talk about what are different ways ARM could adapt to the new priorities for our administration, and large impactful weather events, the energy system and things like that are one of those topics that popped up. So I was kind of curious to see, are people interested in simulations that would address that? And at least in the top 3, people aren't thinking this way yet, but I encourage all of us to be leaning into these where we can, because they'll probably benefit us in the long run. But so just in summary, some of the recurring themes combining both this kind of more statistical look at the different topics with the free-form feedback that I allowed users to provide as well. So the aerosols are definitely of interest, top choice in terms of first rankings. The boundary layer and land atmosphere interactions popped up multiple times in the specific comments, so there's interest in that as well. My impression looking at the specific comments is that the interest is in deeper clouds over shallower clouds overall. And there were multiple comments specifically asking for spectral bin microphysics, which runs the cost up, obviously, but that's something we can be looking into. Multiple people were commenting on the need for coupled soil models with the atmosphere and the importance of that for these simulations. And it tended towards more of an interest in what I'm calling here real boundary LES, as opposed to more idealized LES. And then often combining that with larger mesoscale simulations, kind of like we did for cacti, where we had kind of a multi-scale approach from the kilometer scale grid spacings down to the 100-meter grid spacing. So that's kind of where the big picture is for topics. In terms of the number of simulations, it seemed to be kind of a sweet spot around maybe the 15 to 30 cases is about the right number for a lot of the users. And the reason I asked this is because I've had a lot of people ask, are you going to do continuous simulations where you're doing them every day or for a whole season or something like that? And it seems like most people are satisfied with a fewer number, but a little more intentional focus, shall we say. So that was interesting to see. And then the other thing that's kind of unique to ARM in its lasso activity is we typically do ensembles around the case states we select. So instead of just a one deterministic simulation, we'll often do multiple simulations by varying the forcing, sometimes model configuration. So I asked a question around that, and this is the results on that. The most important desire there is the variability of the input forcing. Over 70% of the people showed an interest in having that kind of ensemble member. So that's probably something we shall definitely keep going in the future scenarios. Smaller numbers for these others, whether it's statistically different, we could probably not, but there's definitely interest in all the different kinds of ensemble members that we produce. And one of the surprising ones, we haven't done a lot of model variability ensembles in the past, but that actually popped up as something over half the people were interested in seeing. So that's something we might be wanting to think about as well. So any questions on feedback from the surveys that people might want to note or comment on before we move on to the next options on that? Yeah, Jim, go ahead.
I guess I would just make a comment about the lack of responses to impactful weather. I would say that's a little bit vague as to what that means, and I would
That's
argue
very
that
true.
deep convection, one might argue, is often impactful. So the interest in deep convection, I would say, is consistent with interest in impactful weather, or could be.
Yeah. I was kind of hoping that when people responded to that, they might, in the free-form inputs, kind of describe what they were interested in that, like as a lightning, as a high wind events and things too. So, yeah, Dave, go ahead.
Do you have a sense from other experience about for the real boundary condition simulations of, say, an observed mesoscale case, how successful or accurate do you feel like the simulations would be for the mesoscale development? Like, how, so
Yeah.
a wildly inaccurate run can be useful for diagnosing what's wrong with the model, but less for physical processes. Just
Yeah, exactly.
an opportunity to like talk about that.
Yeah, it can be case dependent, to be honest. So for example, in cacti, we targeted about 20 cases at the kilometer scale grid spacings, because a lot of those systems are very well organized and have a significant upscale growth in MCSs and things like that. And we wanted to make sure we captured that at the coarser grid spacings before we attempted the large eddy scales. And in the end, well, one, we couldn't afford to do LAS for all 20 cases, but of those 20 cases, we weren't confident in at least half of them really doing well at the LAS scale that would make it worth doing that. So that's one of the reasons we really kind of intentionally focused down on smaller number of cases.
So similar strategy.
Yeah. It'll be a little different at BNF because in cacti, it was orographically forced, or at least influenced heavily by the mountains in that region, where BNF, it's much more open. A lot of the organized severe convection is synoptically driven from frontal passages and things like that. But there are in the like isolated convection days as well. We have an example slide for one of those. So how we pick cases might be a little trickier, and we might need a little more testing this time. The advantage over BNF, we have much better local observations, and because we run the forecasts here every day for her down a 3 kilometer grid spacing, so we can get some indication of how well a case will do from those.
Great, thank you.
Yeah, G1, maybe quick comment for you, and then we can move on to the next slide. Go.
Hi, yes, Bill. My question is that it's indeed very interesting that aerosol and trace gas processes ranked very high, but I think in your lasso configuration you don't have those processes, right? For the aerosol, you probably only have like initially you prescribe like aerosol.
Yeah, historically, we've kept aerosol intentionally simplistic. But we don't have to going forward if we can find the right configuration that's useful to the community. So I actually have a slide later on where I'd like to have a little discussion around if we did this, what would people be interested in seeing? And if we can kind of discern what that might look like, if that's an appropriate direction to go.
Yeah, that's involve significant probably additional model development. And the other thing is about here, you show the model, different models. This mainly involved with like a model in comparison project. So is that something in your mind to do, or it's just this is come from
My personal
survey,
opinion would not to be go with the model intercomparison for model intercomparison's sake. I think that's more appropriate for something like a MIP or something like that. And LASSO traditionally hasn't been like MIP focused. But again, it's kind of what will serve the community best and what will get the most traction and most value is what we're looking for. So,
thank you.
sure. Yeah, along those lines, I think some of the interest in this multiple model, checking the box here. So traditionally, we've used the WRF model and the SAM model in LASSO. Those are well-founded, long history models that have been out now for decades for both of them. There's multiple models coming on the scene now that are more efficient, that DOE is investing in, that could be used for LASSO. One of those is the screen model in its various versions, shall we say, I guess, whether that's regionally refined or doubly periodic mode, or, well, I doubt we would run a global multi-kilometer grid, but that's, if you really push screen to the limits, that's where it can go. So that's a new model coming on the scene that DOE is investing quite heavily in that could be of interest to this community, as well as the energy research forecasting model that's getting pretty close to usable like production stage. There's multiple DOE labs working with that now and testing it in various modes. So whether it's to the point that would be appropriate to use for production LASSO simulations would be a good question. But so SCREAM and ERF are both out there. So we could be running side by side with something like WRF to help validate these new models. But whether ARM is the right people to validate the models or we produce a simulation and somebody else does cross validation, those are all questions that probably should be addressed at some point. So the next part of the hour I want to spend with a little more feedback and kind of getting discussion going. So we've got a couple example scenarios just to kind of give folks an idea of what would it cost to do different types of setups. And then I want to hear from you all, would you use these kinds of simulations? How would you tinker with them to get them a little more appropriate for your needs? Do you have other ones to offer that we should be looking at and considering, that kind of thing? So I have a couple slides to get everybody kind of oriented in terms of how I think about scenario design and development, and what might be helpful for you to be kind of pondering as we talk through these different options. So in terms of threading the needle, there's different things we need to kind of balance to get the right scenario. In terms of our overall goals, we want to bring visibility to ARM's unique capabilities and ARM's instrumentation that's out there. Obviously, we're funded by ARM to do these simulations, and focusing the community on all these great observations ARM is taking is one of the values of LASSO. So we want to make sure that happens. The second bullet is providing what I call the right level of foundational modeling to inspire and enable the research community. ARM itself is not doing LASSO to do the science. My team, we generate these simulations, but we're not funded to actually go out and do all the really detailed state-of-the-art science with them. but we want to encourage others to do that with these simulations and enable others to do that. So we need to provide enough information that it speeds people up and really gets them inspired to go out and do this, and finding where that level is without going too far and getting into the actual science ourselves, which is fun, but there's other funding to do that. That's not ARM's job. Then the next thing is we want to maximize simulation use. So one of the hard things for me is figuring out what's the right level of simulations or design configurations that will get the broadest number of people working with these simulations. We don't want to do something that only is tailored to in an extreme case, a single PI project. We do this great product, that PI is able to pick it up and do a lot of great work, and we empower that PI, but nobody else has any interest in it. This is a user facility activity, so we want to make it something that a lot of people are going to want to pick up and use. So we want to maximize that broad acceptance and excitement around using the simulations. And then the last bullet is kind of the practical. We're budgeted roughly about 2 petabytes of tape for each scenario, and about 2.5 FTE a year to make this happen, and roughly 100 to 110 compute nodes on ARM's cluster. So that's kind of our hard limitations. We can't go past that. So if we need an exascale computer to run the simulations, it's not going to happen, obviously. But still 100 nodes is 128 cores per node is quite a lot of power, and we can do a lot with that. We just got to kind of find the right balance for the number of simulations versus number of cases, domain size, and all these kinds of things. The choices we actually kind of have in our control around these scenario designs is, one, selecting what the science priorities are. So is that detailed aerosol studies, or is that detailed cloud microphysics, some compromise that allows us to afford to do both at the same time, that kind of thing. Domain size and resolution obviously is the biggest kind of knob we have to turn. Model complexity is another one. So for Eastern North Atlantic, we use spectral bin microphysics for most of our simulations, which was something new for LASSO for that scenario that we haven't done in the earlier scenarios. That obviously adds cost, but depending on the science that we want to really target, sometimes that's where we need to go. So that's what we did. Number of cases, how many different dates we run is double the number of cases, you double the size of your output, obviously, that kind of thing. How we do ensembles also makes a big difference. So for cacti, we use very large ensembles. For shallow convection in ENA, we use smaller ensembles. But that's something that we can look at and think about for BNF. And then obviously how much model output we save. Do we do it every 5 minutes, every 15 minutes? Just that this is right, there's a factor 3 difference in how much we can save. So these are all things I'd like you to kind of keep in your mind as we go through this, and use this to kind of influence how you ask questions and think about what we might be doing. This is kind of not related, different ways to think about the questions. So what kind of simulations are necessary to advance the science? So if we're going to focus on a particular science topic, what do we need to do to have simulations that are appropriate for that? The level of complexity, domain configuration, number of cases, number of ensemble members, whether or not we do data assimilation. I'd be thinking about who would use the simulations. Is there something we can do to make the simulations more useful to a broader group of community, a broader number of people within the community without making too many compromises? Who would want the simulations, but maybe the proposed approach isn't going to suit their needs? Is another kind of way to think about that. And also, how do the simulations in the simulation approach relate to high priority interests for DOE and for ARM? So these are the kind of big picture questions. Burn those into your brain, and then we'll kind of dig into some specifics right now. Anything in the comments, Scott, or questions people might have?
Nothing in the chat. And just a reminder, I've also had the links in there for the BNF survey, so you can still fill that out as well. And the other links for the Lasso email that you can sign up for.
Great, thanks. And feel free to raise your virtual hands and interrupt me as we move along here. Particularly going forward now, I want this to be as much of a discussion as me just rambling on. So So here's an example of a very practical scenario that we could do for the Bankhead National Forest. And this is, I would say this is a highly likely configuration in some sense. So let me know what you think about it. So isolated deep convection obviously is important to a large portion of our DOE funded research community here, as well as NSF. Isolated convection happens at BNF, and we've got pretty good observing system to sample those as well. So what we could do is something similar to a cacti configuration, where we basically ran coarser simulations to basically get the background input fields. Those would probably be driven by a combination for ensembles of the HER, as well as ERA 5, maybe other ensemble members as well for forcings. But the ultimate goal would be a primary domain of interest with 100-meter grid spacing. It's probably about 150 kilometers wide, because it needs to be big enough to capture some of the domain variability around the BNF location, as well as spin up for turbulence and everything on the inflow boundaries, and have enough of the life cycle of the clouds as they develop and stay within the domain long enough to do the science. So the simulation period at that highest resolution would probably be about 12 hours, kind of like we did for cacti, but the outer domains would run for a day or maybe longer to get the background conditions spun up and to kind of see the larger context of what's going on. The model setup could either be the WRF model or the newer EARF model. The cheapest way to do this would be with P3 microphysics or some other bulk microphysics, but we could look at ensemble members that would include spectral bin as well. If we did this, it would probably be about 13 terabytes of simulation data per high-res LES simulation if we follow something similar to what we did for cacti, and that was with 5-minute output or things like that. It would take about a week to get a simulation out of the cluster if we ran it on 55 nodes. So we could probably run about 2 simulations at a time as we're working through this, and it would take a week is considered reasonable in our minds for that. So that's option number 1 for what I'm calling isolated summertime deep convection or local deep convection. Option number 2, and I'll present this and then we'll pause for some discussion. This is a focus on the more organized, big scale convective systems that come through. So squall lines, other types of severe convection. So the science focus here would move beyond just the convective initiation of the local small convection to more what we might call the high impact or high winds, impactful weather events, deep convective processes, as well as the organization of those. This would require a larger domain size, potentially up to 500 kilometers wide. So to balance the cost of that, we would reduce the LES domain resolution down about 200 meters. I think we could probably still pull that off. Simulation period would be on the order of a day again, whether we do that all at the high resolution or a nested approach like I described for the isolated case, either one of those would be appropriate. The model setup again could be WRF or EARF, bulk microphysics, just to keep it more cost efficient. And on the right, this picture here is an example of something I've done like that for MC3E simulation. So I'm showing here isosurfaces with a 400-meter grid spacing. This particular simulation also had I think it was a 100-meter grid spacing nested in that. There was actually moving domain that followed the frontal passages that came across SGP. So that's something it's much bigger, a lot more to look at and kind of understand in terms of the cloud processes. Because the domain's larger, we could only store maybe 30 simulations within our 2 petabytes of space if we still output every 5 minutes. We could compromise on that, obviously, to stretch it out more. It would take about probably 2-ish weeks to get a simulation out running 55 nodes at a time for this kind of setup. So what do you all think? Would these types of simulations of BNF be useful? Is there something that could be done that would make them more useful for research you anticipate at BNF. Your thoughts? Yeah, Dave, go ahead. You got your hand up first.
Of course, everybody always wants more of everything, so trade-offs, but
Yeah,
it can be useful to have cases that ended up with isolated convection that you might have thought would go to mesoscale or severe convection as a complement to some of these organized, more severe cases,
Yeah.
because at least for us, part of the interest is like, can you tell, or is there a, is there a, you know, are there more clues in the
yeah.
environment?
Adam Gorbel would call these null cases for cacti. So
Mhm.
one of our case studies actually is what we might consider one of these null cases where the convection didn't really develop like we thought it would.
Mhm.
They're a little trickier to pick out and try and find in the data sets, but they do exist. That's something we can make a note.
Mhm.
Yeah, John.
Now I'll give my feedback, given that I live down here and I've been here for over 20 years. I will say that the convection, the nature of the convection in summer, so after May, when you get between like, especially June, early June, and maybe middle to later August, is we get an awful lot of days with where the convective storms practically do not move. They form, rain in place. They may drift, you know, very slowly, like we're talking 10 miles an hour or something. So I do think the setup for Lasso is going to be pretty good with that, in terms of if you do get storms that form in and around the BNF, you know, they're going to be well captured kind of over their life cycle. You're probably going to get a lot of that. In terms of the organized convection, yeah, I mean, I think that might be a little bit more challenging, because certainly when even you know, the synoptic situation here can be somewhat active into June and obviously in the spring, and then you just get this rather quick motion through this relatively small domain. But yeah, those are my thoughts. I do think it's somewhat unique here in the fact that the convection is it really doesn't, you know, it's remarkably slow moving at times. So
Yeah, we have an example of one of the isolated convection days in one of the slides later on, just to show people as an example. And if I remember right, that one is one of it's semi-stationary for some of those more isolated cells. And that actually is great for something like Lasso, because you don't have to have as large of a domain that way.
right.
The fast moving organized systems, they're hard because they're going to require substantial outer domain to capture things properly to scales where you can afford that and then get down to higher resolution. Yeah,
Yeah,
so
it almost speaks to a, you know, you could have one approach for the warm season and another modeling approach for the more advective convective seasons. And when the storms are advective too, of course, they're more organized. So
yeah. And we can also draw upon other modeling that's done in the US for like the HER as well. When we see that it's doing well for a day, that can also probably bode well for us to set up the larger simulation on that day as well. But
yeah.
yeah, definitely multiple configurations for different case types is probably likely.
Yeah.
Just to manage
Okay.
costs.
Just to
Yeah.
point out some questions in the chat first before going to Ja. There was a question in there just again on reiterating the estimated output for the storage estimates that you were giving.
So I have different one here. So I estimated these amounts based on the cacti simulations and scaling it for numbers of grid points and the output times. So my target was to how many of these large simulations would fit in 2 petabytes. And if we do a combination of simulation types with large and small domains, obviously, if you have got 1,000 small domain, the coarse, small grid column count domains with coarse resolution, at some point it'll eat into what you can say for the LES, but proportionally the LES is almost all of the cost for the saving and the storage. So that's the numbers I've got on here right now. So 13 terabytes per sim for the isolated 150 kilometer domain, and 74 terabytes for simulation at 200 meter grid spacing, 500 kilometers wide.
And I guess one other thing from the chat, just as it related to John's, was specifically there was a question on including interactive land or prescribed land surface, and I think it also speaks to possibly some of John's comments there. If you believe that convection is firing repeatedly over the same location, may likely be because it's previously rained there or other
Yeah.
complications to that. And so,
Yeah, pretty much all of these simulations I'm talking about today, in the back of my head, I'm assuming we're using interactive land surface, whether that's NOAA-MP and ORF or something equivalent in other models. And the HER model runs NOAA-MP, so we could use that to initialize the simulations, or we could do something like cacti if we deem it appropriate to spin up our own land initial conditions. So yeah, sure.
Hi, thanks. I have some comments with the storage or outputs, but I'll go to my questions first. For this, like these more organized events, is there a possibility of doing something like what you mentioned of a moving LES domain within a nested kilometer scale, where you can, you can run a few kilometers covering the entire system life cycle possibly. And then within that, you can set up a moving LES so that you are following the part of the storm that require high resolution to look into the details. I know that's a lot more complicated than just simple nested.
Yeah, technically it is possible. And for example, the image on the screen here, the next simulation that refined beyond the one I'm showing, it actually had a moving domain within that kind of propagated across Oklahoma. It generally worked. It's definitely saves a huge amount of cost. So that's where it has the big advantage. If we did that, we'd want to experiment and see what's appropriate. And then obviously, where will it go within ARMS observations and cases appropriate for that.
Right. And then my other question regarding the outputs, based on our experience working with the cacti simulations, it will be beneficial, at least for the people who are interested in deep convection, certain type of outputs where allow you to follow the life cycle of deep convection a little bit better, to have more higher frequent output just for those like limited variables. For example, for the purpose of tracking the storms, you don't need all types of 3D outputs at very high frequency. Those would eat up into the storage, but certain type of 2D variables you can output at way more frequent than the 15 or 5 minutes that would constrain the storage. But
yeah, that's definitely something we could look into, particularly for 2D variables. We did that for ENA with the SAM model, where the more traditional LES statistics are quite frequent, but the 3D output is only 15 minutes, if I remember right.
And then certain type of online diagnostics that we could run would be even better. Some of them that could be expensive to run like offline because you require multiple 3D variables, but if you can actually run it online, that would be very useful. But it'd be great to have inputs on designing these kind of type of specialized outputs from the community, that we know, oh, if we have these outputs, more people will use them because they don't have to bother like calculating these posts in post.
Yeah. So you're thinking like PyFlex Tracker or Tobac? Or...
No, like something like, something representing the convection and then the environments, like something that you need to integrate, like CAPE, whatever things like that, they are expensive to calculate or require multiple 3D variables, so we can calculate them online, which depends on the model. Like WRF have some of those. Some other models might need to develop in, like Scream, if you're decided to use that. But yeah, especially for big, expensive simulations that you don't really want to do this after the fact.
And we did a lot of this offline for cacti, and then 919 did additional ones offline. So we could optimize that more this time around.
So
I made a note.
That's all I want to say. Thank you.
Talk to you about that.
Ji-Wen.
Hi, my question is about for this location, I think of course, shallow to deep transition, isolated convection are interested science. On the severe storm side, I'm wondering is a significant concern over this region. If not, then probably less justified. Particularly given we are required to work more with stakeholders, the interest from local, all those things.
Yeah,
So
there's definitely severe events. It's not going to be the same as SGP, obviously. But for example, during the Armed Summer School last May, there was a tornado event that came through, and actually I spent the evening in a tiki bar basement, waiting for the tornado to go past. So they do happen. And Scott's commented we've actually sampled deep convection in general, depending on what you consider the threshold for severe. But we've definitely had a lot of great events happen in the last year. We've had observations that definitely have high quality, good radar stats and everything. And we anticipate going forward now as get more and more of these instruments operating at the same time and consistently going forward, we probably will have more cases to anticipate this year and in the coming years as well. So part of this is coming down to like how much do we specifically wait for those, or do we do maybe two different kinds of scenario options as cases become available, and then maybe do a isolated and severe simultaneously, something like that.
Yeah, connect back to the survey. Seems like the interest on the severe weather is not that much. Maybe it's because traditionally for the severe weather, we are not going this location to look at those severe storms. But yeah, deep convection definitely. I mean, deep convective storms, those general, particularly the properties like radar reflectivity, updraft, downdraft, cold pour, those things. It's different from what we're talking about here. More focus on the impactful weather, which is have like damage winds and damage hailstones, of course tornadoes. It's require additional configuration, even in the model. The model, for example, if you don't want to look at the tornado related processes, then it's some different outputs. Like for hailstones, the same thing. Different outputs needed.
Yeah.
So
Or like,
it's
for
just
example,
a big
if we wanted to look at
decision.
lightning, we would have to make sure we find a microphysics parameterization that works with lightning parameterization, and
Yeah.
would,
So it's just I want to mention that there's additional efforts toward
there's
that
more choices that'll have to be made.
direction. Yeah. Okay. Thank you.
So thanks. I know this feels rushed, but we're going to run out of time. So I want to make sure we move on and touch on a couple other topics as well. And Scott and I can stay on the line after the hour to have additional discussion for whoever wants to stick around. But I want to move on. Just two more examples here, just to give people a sense of what could be done. This is something totally different. This would be cloud-free. This would be looking at boundary layer processes and in the forest turbulence and above the forest turbulence, that kind of thing. So the energy or the science focus here would be more about energy and tracer fluxes within and above the canopy top. This would be something really taking advantage of BNF's tall tower and some of the capabilities we have at BNF that we have not had at other ARM locations. So here we would be running very high resolution, probably on the order of 2 to maybe 10 meter grid spacing. So I priced it out here with 5 meter grid spacing, 10 by 5 kilometer wide domain, which is probably larger than we could afford, but just ballpark. On the right's an image from a paper that's done this kind of work, Clifton et al. In 22, with their model, they went down to 2-meter grid spacing, and that particular image is showing vertical velocity inside the forest canopy. So obviously simulation periods would have to be short for this kind of simulation, and most likely would use something like a precursor domain methodology, which is a little less traditional for a lot of us weather modelers, but it's something very popular in the wind energy community and in other engineering applications where you run an outer domain to spin up turbulence that's periodic, and then an inner domain that has more of the time-dependent boundaries where that turbulence comes through the boundary, and then you have your more localized features from the forest and variability within an essentially overlapping domain on top of that periodic domain. So this very rough estimates here. I didn't have time to pull specific numbers on an appropriate model to do this kind of thing, but very rough scaling with WRF, it would probably take about 13 weeks to get a simulation out on the 55 nodes, which is beyond what we could do here. But we could probably drop that by an order of magnitude if you get the right model in place to do this. Is this something that would be of interest to anybody or not? I'm going to present one more slide, and then we can stop and see, is this something that people think we should be looking into, or we just don't worry about it because it's kind of outside of the focus of where we want to go. So the next slide here is aerosol. I mentioned I'd have a slide on that. Because I know a lot of people are interested in aerosol, I want to make sure the aerosol community has a chance to kind of speak up and say what they would like from LASSO, and see if we can essentially adapt our techniques and find a configuration that would be useful for them. So I want to give folks a chance to offer what they would consider important science drivers if we did aerosol modeling at ENA. Some examples could be new particle formation, looking at variability of aerosol plumes and where they're coming from in terms of what's impacting the BNF site to better inform what's being observed on the surface there. Scott was mentioning that Shanghai was interested in leaf on and leaf out. So the week or 2-week period when the leaves are transitioning in the forest, how does the aerosol and processes around that change? So that's something that might be an option. And then obviously a question that I have is what's the right level of complexity for the trace gas and aerosol models that we'd be looking at? Is there something that would be usable by a wide number of aerosol essentially the groups working with those aerosols? What weather regimes would we want to focus on and that kind of thing? So with the forest canopy and aerosol, let's open the floor and see what people have to say on that. I don't see numbers next to, but I see Rob, you're the first one.
Rob was the first, Rob Jerome, then John.
Okay, Rob.
Yeah, I think that's very interesting. I think there's a lot of interest in this area for aqueous phase cloud processing of aerosol, I think. Thinking here organics, kind of more cutting edge stuff. Don't know how much simulations could serve that exactly, because it's likely to be chemistry that's way beyond what you can put in a model at this point. But if there are ways in which, the things like aerosol surface area could be kind of kept track of, just to sort of, so that it's friendly to sort of people who are interested in more of the chemical processing. Thinking here as surface area as a sink for a lot of things, aerosols and trace gases. So yeah, I don't know what that offers in terms of that points to in terms of what you need to simulate or what model you should use, but I would say that's an area of interest for the chemists for sure.
Yeah, and something kind of related to that, even if LASSO doesn't run the actual chemistry for complicated organics and SOA formation or things like that, we could do adaptations to have the right outputs to run box models using our output or something like that. We can optimize our configurations in ways that would help the box modelers to have the inputs for their meteorological details and things like that. Yeah, Jerome.
Yeah, I had a similar question. When you mentioned new particle formation, I was sitting there going, I don't think you really meant that you were going to do full chemistry, you know, because you would kind of
It,
need.
it depends on the community need, but yeah, that would be
Well, that's like
asking
an
more than
order
we
of magnitude
traditionally
more
do.
time and space, which I'm presuming you don't have.
Yeah,
So I mean, you know, thinking of that, maybe if you were thinking about aerosols, I think it's like something more simpler to do, which is sort of like things you may have done for ENA, where maybe you're just perturbing aerosol input, you know, and seeing what the effects are of aerosol input on a very simple cloud aerosol interaction kind of treatment, sort of thing.
yeah,
But getting back to the other comment I have would be, it would be very useful, like you were saying, to do the explicit chemistry, is maybe if you could actually coordinate with Israel to do trajectories from ARM simulations,
mhm.
so that we could do box model chemistry calculations along those simulations. That would be rather useful because you could follow those trajectories in and out of clouds and through various boundary layer processes. So actually providing trajectory information from these cases would be very useful as well.
Yeah, yeah. So then it's coordinating the right output frequency and the right variables to make that happen. Thanks. Yeah, John.
Yeah, I mean, when you said leaf out time here, I don't know if this is something that's in anybody's science plan, but it's going to be a tracer no matter what. There is an absolute ton of pollen down here in the springtime. It turns things yellow. I mean, it lowers the visibility. So I do think whether or not you're looking for it or can use it in anything, you're going to see it. And then it begs the question, does it have an impact in cloud microphysics? I don't even think there's a aerosol microphysical scheme that could be aware of pollen, but I just, like I said, I thought I'd bring it up because it's really a different animal down here in the spring.
Yeah, it's kind of the hot topic for ice nuclei and what role that's going to play.
Yeah, I won't speak for Chungai on the comments that he was relaying to me, but as mentioned in the chat, Allison Steiner and folks at Brookhaven are currently dealing with different ways of parameterizing what happens with pollen, specifically with the processes and situations where you have higher relative humidity. So I think if they would like to speak to that or are able to speak up, then by all means. Chungai posted something in the chat as I was saying that.
Yeah, John guy's comment about resolving the transport of essentially the biological aerosol in the canopy and stuff. We could either do that very expensive, like the previous slide here, or something more simple and parameterized.
Yeah, the question I would have had, and maybe it's for Jerome because I'm less familiar with the trajectories, but when you're talking about back calculating trajectories, would there be particular sizes or quantities that would be related to the sizes of things that you want to get the back trajectory of? Because it seems like it would be a little bit more complicated than just the straightforward back trajectory, I guess, if it's related to particular sizes of particles that you're interested in.
No, I was just really talking about just getting position of the trajectory and then the meteorological variables along the trajectory, because those things could be used to drive our aerosol chemistry simulations. So I wouldn't necessarily rely on a lasso run to say predict aerosols. You know, I'm relying on it to do the boundary layer properties and clouds.
Okay, thank you.
There's been some work from Susanna Burrow's early career project that's done something kind of like that. I know we're at 2 o'clock. There's one other topic I want to make sure we hit upon. So I'm going to fast forward here and we come back to these if people want to stay longer. But one of the questions I had in the survey was if people are interested in data simulation and what traditionally, well, I don't know if it's tradition. The term that's been thrown around LASSO ever since we started and before LASSO even became a term, the 4D data cube. In the early days of LASSO, it was proposed that essentially what LASSO could be is to create these 4D data cubes, which could be interpreted different ways. One would be something that is very tightly coupled to the actual events on a particular case day. So you literally have clouds almost as close as possible to where they happen, so you can match your radar observations to them with the model and things. How to do that is complicated, and what level of expectation would be is something I'd be curious to hear about from the community. Basically, the way to do that would be through a version of data assimilation, either with the radars or LiDARs or whatever instrumentation you can throw at the data assimilation systems, essentially. In terms of the survey, there wasn't a strong opinion, yes or no, but almost everybody said maybe. And I think part of that because a lot of people don't know what is meant by a 4D data cube and what might be possible with data assimilation. Some of the concerns that people shared in the freeform comments were concerns about data volume, particularly if you're doing data assimilation at the higher resolutions, LES scales. I would expect if we did data assimilation, it would probably be down maybe to the kilometer scale grids or couple kilometer scale, similar to what HER would have in terms of grid spacing. But that's also something that we can debate. There was a suggestion to tiptoe into data assimilation just to demonstrate it for a few cases and see what we could do. We could use data assimilation as one of our ensemble options among many simulation setups. There were concerns over the non-physicality of data assimilation, and essentially because you get jumps in your time series whenever you have an assimilation cycle, that can make the simulations inappropriate for process studies. There's also a concern, which I very much echo, is we want to have very clear expectations and clarity around why we want to do data assimilation, and then choosing the right data assimilation that would get to those goals. So that's something, if we're going to do DA, we want to make sure we really carefully think about. And then there was a concern shared in the comments, which I am concerned about as well, in terms of the budget. Doing DA would require a lot more effort. So we would probably need a larger budget and things, or that. So it might constrain how many cases we could do in total, because I'm assuming Jim doesn't have an unlimited pot of money. So those are some of the big picture questions around the DA. Oh, there's also the comment we could leverage LASSO's ensemble approach as one way to do ensemble bearer approaches, which was kind of an interesting comment. So some questions that I'd like to get some input on. Should LASSO apply formal data assimilation to constrain our simulations? What scales would folks want that data assimilation to be constrained down to? Should we only apply it to get the analysis or initial conditions, or should it be something more like ongoing assimilation where it's going to happen throughout the simulation period? Are there particular types of DA that you would recommend that we look into? There's many different kinds out there, depending on what the needs are. And then if we did DA for LASSO, how would that change how you approach using LASSO simulations for your work? Do you want tight coupling between simulations and observations? Are discontinuous time series a problem for you? Or is that something that helps because you're more tightly locked to the obs? And also, would a probabilistic approach be useful instead of a deterministic one? Because depending on the DA approach, when you do the ensembles, we could take a more probabilistic view of the world. So I'm kind of curious to see what people have to suggest on this. So let's open the floor on 4D data cubes and DA. Yeah, go ahead, Rob.
Yeah, I guess one question I didn't respond because I'm probably one of the people who said maybe because it's exciting to think.
There's definitely possibilities there. Yeah, it's like, what's the right way to do it if we want to do it at all?
And I guess the question I have, which maybe helps, would be if you're then using all these data to assimilate, what is there then there to compare with? Independent comparison.
Yeah.
I'm sure there are many things you can compare with that you're not assimilating, but yeah, I'm just curious if there's any thoughts on that.
Yeah, it would change how we would approach the world of the simulations, for sure. So, for example, if we used her to drive our models, it's already simulating the Weather Service radar data and a lot of the satellite data and things like that. What ARM offers is some additional potential radar data, or we could think of it more as using the traditional observations down to a finer scale. And then that might maintain ARM radars independent. There's different approaches we could take. So, Xinglu.
Oh.
Yep, there you are.
So yeah, so I think so the DA could be useful for generating observationally constrained forcing data for running the model. Since the domain contain a lot of ARM measurements, so those data could be used to be fed into the data assimilation system, and then kind of generating more localized forcing data that can be used for LASSO simulations. So I think that's a very complementary approach that can be applied here. So yeah, I think it's very promising.
Yeah. So if you did that, what scale would you go down to?
So I think in mesoscale, like 1 to 3 kilometers,
So
in
similar
those
to her.
scale of simulations. Yeah.
Yeah, that's probably how I was picturing it as well. But the question is kind of like, where do you start and stop?
Yeah. So in my previous work, we have done using different profiling measurements to be assimilated into the model, and then try to better predict the shallow cumulus over SGP area. So those are very interesting result that I think that highlights the boundary layer moisture is pretty important for simulating those shallow cumulus over that region. So I think data assimilation could provide another ensemble member, like I mentioned here. So that could be used to potentially getting more a chance to better simulate a case or an event. Yeah.
Great, thanks.
Thank you.
Koichi.
Yes, just very amateuristic feedback that I'm really data simulation, 4D data simulation would be really great product. And to me, it's really feels like the really fundamental, very good way of using model to supplement ARM, because it's really very good continuous atmosphere and land. So whenever we try to address some science questions, always comes the uncertainty associated with point measurement at that particular time. And then also, if we wanted to ask some question about spatial or temporal scales, we do need continuous field. And then, so to me, if the ARM can really provide kilometer scale, it's probably sufficient, I think. Really interpolated data cube in 4D is very useful to, of course, model evaluation and both process oriented study. That was first things I was dreaming about the LASSO. So I still really want to vote for those data cube as even in the core activity. And then if that activity involves certain, best model configuration and require the source code modifications, and then input data at beta processes script to the community, then again, similar to the current Lasso, the community, once we get enough computing time, we could supplement free running simulations to address our own science questions as well. So one really core, really mother of all data kind of existence is really, I would appreciate, really, yeah, even if that means in less cases, but really more highly confident data cube, continuous in space time. I really want to vote for that.
So you use that for like parameterization development, or?
To me, my own science question was, for example, I'm still interested in what the spatial scale involved, spatial scale
Okay.
with lossless forcing. What is the response of the atmosphere to that? And those, I really have to use model output, continuous field. And then always when I evaluate model, then I have to really struggle to, if it's kilometer scale, the scale difference between points. So I have to do some trick, like maybe extract 10 by 10 grid point around there, or I have to, of course, average over time in cases. That was difficult sometimes for LES case. So if, again, data simulation also can provide some uncertainty associated with that, like for example, ensemble based, then that's also really sanity check of our own model simulations. And of course, parameterization development is, I think it's very useful. And of course, process-based studies.
Yeah. Yeah, that's one reason I was curious about interest in possible more of a probabilistic representation, or essentially that leans towards uncertainty estimates of some sort. So.
Yes. Not concrete idea, but I just voting for the for the
Great,
data
thanks.
cube. Yes, thank you.
So we're about 15 minutes past the hour, and I totally get it if folks need to head out, particularly those on the East Coast, then it's dinner time now. If you have further thoughts, definitely reach out to Scott and me. Let me fast forward really quick here. The lasso@arm.gov is a great way to email Scott and me at the same time. We'll get those and we can respond to you. And there's other links there if you're interested in what we've done already. But Scott and I can stick around for as long as people want to discuss. I'm not sure at 90 minutes Zoom might hang up on us, because that's what it was scheduled for. But we got at least 15 more minutes there if people want to continue to discuss or have thoughts either on the deep convection, shallow convection, aerosol, DA. We'll stick around as long as folks have things that want to talk about. So. Scott, is there anything you want to raise? I skipped over some of the example slides just for time, but we can go back to those if you want to talk about any of that.
Well, I'm also trying to make sure if we hit anyone's questions in the chat that got
Oh,
raised.
great, thanks. Yeah, while you're doing that, I don't know.
Yeah, I have maybe a comment about the domain configuration. For the outer domain, do you have some idea, like you fix those latitude, longitude area, or fixed domain, or?
Yeah, I would anticipate a fixed outer domain and most likely a fixed inner domain as well, but we could entertain doing a moving domain as well if we wanted to do that for a severe case that needed a track to really spin up along the front or something like that.
Yeah, I'm thinking of how to better use those simulations to compare with like regional other global model. I think probably since the at least the land surface heterogeneity might affect those subgrids features within global model domain, either
Mhm.
at like 100 by 100 or final resolution. But since now the like EtherSM low resolution is pretty much regraded to regular like 360 by 180 grid configuration.
For the
Imagine that
analysis
if we
grid.
run the model with single column configuration, probably will take one of the grids. If it's more convenient to register the domain, I know WRF is not strictly by latitude longitude, but
Yeah, we'll call it that though. Yeah.
yeah, but yeah, if it's roughly at the whole latitude longitude, might be easier for the direct comparison. Also share the forcing, the bound, the large
Yeah,
scale
the input
forcing
data. Yeah.
Yeah.
Yeah, definitely that's one of the things we try and do with Lasso is make it easy to reproduce. So traditionally it's been either the WRF input files for the like the nested hindcast kind of simulations or the more idealized settings like ENA, the column-based inputs so that people can reproduce in whichever model they want, where it's appropriate, obviously.
Great, thank you.
Yeah, in terms of like to give a sense of scale, this is the event that came across during the ARM summer school last May. So BNF is roughly right there where the cursor is kind of spinning around. So during the day, there's convection that passes through, and then later in the day, this front basically spins up along the west. It's going to come across here pretty soon. And then this just blows up and then comes across. So the scale of that event is quite substantial. So to do that well, we probably have to have a very large outer domain. How much of the inner domain we could get away with something smaller, we would have to do a little experimentation and kind of see what we could do. Because obviously somewhere around there is the event of interest. So that's basically Alabama-wide event that we're looking at here. So there's the radar for that day in the side of our hotel after the wind gust went past. So
Yeah.
any other thoughts or comments from folks?
Well, so one of the comments or the common threads across the chat for those, and I think few of them are still online here, is there seems to be some confusion as to, or at least questions as to what the HER can assimilate and or, what it currently uses for its land surface model. I guess at one point you might have mentioned NOAA, and there was a question of whether that's the land surface model in it versus, what is it, RUC LSM.
Yeah, I'm not sure if it's RUC LSM. I thought it was NOAA MP, but it could be RUC
I
LSM.
think the comment was
I
that it
don't-
was Ruck, but then
Yeah.
following up to that, my understanding, at least for her, as far as its radar data assimilation is something to the extent of maybe about 4 sequences every 15 minutes taking in reflectivity data. But certainly even within some sort of an assimilation of that scale, it's not necessarily guaranteed to capture the properties of rainfall or
Oh, correct.
other
Yeah.
other
Yeah.
features.
Don't expect miracles, but we
Even
can
in
help
doing
possibly.
that, you would still potentially have better observations from ARM as reference to how well it was doing, but it would tend to steer it in a particular direction towards getting some of that better than not. But I think the thread otherwise was whether or not ARM observations could be further incorporated into her. And I think some of that was exploring not just surface, but possibly the supplemental profiling. And to that, I would simply say, it's not clear to me whether the advantage of assimilating in, let's say, continuous thermodynamic profiles from those ARM sites, say based on TROP-OE, Doppler LiDAR, or something like that in the boundary layer, would that be would that be easy enough? Would that be easier to do than simply, say, having an IOP or other requests for launching additional radiosondes at those locations? Something that may be a little bit more straightforward and potentially of higher fidelity or quality for those locations. So there may be better ways to accomplish it than trying to do it a hard way with, a mostly boundary layer thermodynamic profiling.
Okay. Yeah, those are good thoughts.
I don't necessarily see any other comments other than Jerome's comment of AI performing miracles. So hopefully, yes, that will also happen too. But I think we're still at 30
Yeah,
people.
we're down about 30 people. So yeah. Yeah, in terms of AI, I intentionally did not ask those questions just due to time today, but if folks have thoughts on how we can optimize Lasso to be incorporated into AI workflows, that would make ARM very happy and DOE in general very happy. So definitely reach out to us if you have thoughts along those lines. So well, it's looking like it's a good time to call it a day. Thanks everybody for sticking around and have a good evening.